Okay, we are in 10-3. This is the homework assignment for 10-3. If you guys want to write that down.
Right.
2 through 20, the evens. This is for Olivia and Remington.
Say it.
I can't say that.
You can't hear me.
Remington, they looked up your name in Chinese, and they think it's like the coolest thing ever, so whatever. Whatever. So Olivia and Remington. There you go. Or whatever they said. Homework assignment 10-3. You think so? I'm going to say it. I don't know how to say it to begin with. Whatever. All right. Okay, all of these examples are going to be really short, except the last one is the hardest one, and there's a little bit of thought that goes into that. But otherwise, this is pretty straightforward. Here we go. We are doing arcs and chords. So refer your attention to the middle of the first page of notes. This little diagram, do you find him? Here he is. This is called circle what?
Does this require knowledge from the previous?
No. This is called circle what?
Are you saying
Circle L. This is circle L. So if you were to name him, you would call him circle L, right? And you can name him like this, circle L. Yeah? That's how they'll name him. Okay? Now, there are some things going on here. There are two chords is what they're called, all right? FG is a chord, C-H-O-R-D, and JH is a chord. What has to happen in order for it to be called a chord?
Has to connect.
Connect how?
Between two.
End to end.
End to end of the circle. So for example, like this is a radius. Is that also a chord? No, because this end does not go all the way to the edge of the circle. Now, is a diameter a chord?
Yes.
Yes, because it goes end to end, all right? But FG and JH are chords that are not diameters. So those are chords. Now, here's what they're going to start doing. Ready? Okay, each chord, imagine that like this is a pizza and for some reason I'm taking a knife and I'm like slicing it off right there. Like that would be a stupid way to slice a pizza, but whatever, right? Maybe if you like a crust, whatever. We're slicing it that way, okay? We are having these chords, we're having these chords create arcs right here. Like this is an arc and this is an arc, right? Okay? We could, if we wanted to, pull this back and create a central angle also. So like instead of doing this slice of pizza like this, do you see my slice of pizza? I'm like cutting just the crust off of that slice of pizza. That's what I'm doing, right? Okay, so I have a chord and I have an arc, okay? All right, let's say that this angle right here is, I don't know, that looks like maybe 70 degrees, okay? What's the measure of the arc?
Like the length.
No, just the measure of it,
70 degrees.
70 degrees, right? Now, they would have to give me the measure of the radius in order to figure out the length, but whatever, okay? 70 degrees, got it? Let's say that they say that this chord right here is 2 inches, right? Let's say that that's 2 inches. Let's say that this is 2 inches as well, right?
No, the outside.
Really?
Whatever.
Oh my
Okay.
God.
I get what he's saying. Like this would be bigger than 2 inches, right? If the chord is 2 inches, the arc is going to be bigger than 2 inches because it's like rounded, right? I get that. I understand what he's saying.
Put a ruler up
I
to that.
gotcha. You're fine.
small
Okay.
amount.
So this is 2 inches. What's the measure of this arc going to be?
You have to.
This is 2 inches, right? What's the measure of this arc right here? What?
Oh no.
Would it be the same as the other one? So what's his measure? 70 degrees, right? So if I am taking the same slice right here, 2 inches, 2 inches, this is 70 degrees. The other one's also 70 degrees. You see how that works? Yeah? So you're just like taking equal slices out of this like pizza thing, whatever, all right? Go down to this diagram. Ready? Diagram right below that, okay? This is from A to B. What's like that thing? From A to B. That's a diameter and a chord, right? Okay. So this specifically, if I want to be really specific, this is a diameter. XY is a chord, but it's not also the diameter. True? This is just a regular plain old chord. Okay, now, here's the deal. This is where it's important. Where they come together, it's making a perfect T, like a perfect 90-degree angle, right? Now, something special happens with that when that happens, and it is that this side is the same as this side. Think of it like as a kite. The two sides are the same, yeah? Okay, here is what is not true. Are you ready? Here's what's not true. This guy is not necessarily the same length as that guy, right? They don't do a very good job of showing that, but let me show you that in like another example. You don't have to draw this, but let me show you, okay? Let's say I have my T going across here, and let's say my chord looks like this. Is this the same as this? Obviously not, right? But what is the same? This and this are the same. Only if that's making a 90-degree angle. Now let me show you what it looks like with not a 90-degree angle. Whoop. Is this the same as that? No, when it's not a perfect T, a perfect 90-degree angle, it's not going to split it in half. True? Okay? All right, so be careful of that. All right, let's go and do an example. That's what these little tick marks mean. Boop, boop, right? Tick marks? Got it? Okay. Let's go to, I don't know, our first example right here. Example 1. Okay? Go down to example 1. They're having us look at this diagram and be careful with some of the terminology. They say JK and LM, straight line JK and straight line LM are the same. Not arc LM. Arc LM is different than line LM. Okay, let's talk about line LM. LM and JK, those are the same length. They have tick marks according to those. It says arc LM, this length right here is, or that measure is 75 degrees. They want us to find the measure of JK. 75 degrees. This is too easy. True? Okay, because the chords are the same, the arcs will be the same. Got it? Beautiful. Okay, example 2. They say in circle C, the two arcs DE and FG are the same. So now they're saying this arc right here is the same as this arc right here, whatever their measures are. I have no idea what they are. Okay, those two are the same. They put little tick marks. Now they're saying this chord is measuring 2x plus 6 and this chord is measuring 5x minus 9. Now what? Set them equal. If the arcs are the same, the chords are the same. If the chords are the same, the arcs are the same. Like this is going to be too easy. Okay? Okay, minus 5x. No, I'm going to minus the 2x. Minus 2x, add 9. So I've got 15 equals 3x. And x is 5, but that's not what they want. They want FG. FG is this one. 5 times 5 minus 9 is 25. Minus 9 is 16. Yeah? 16. That's what we want. Okay? All right, really quick. Let's do something really quick. I'm going to skip that example. Draw this real quick because I know you have a homework assignment like this. And I'm going to do this. This and this. Make like a V at the top. Like downward V. It doesn't have to be pretty. But make sure like this is the same as that. Right? Those two are the same length. Perfect. Okay, and then I'm going to say that this arc right here is, I don't know, 160 degrees. That's probably pretty close, actually. Like half of the circle right here, this would be 180 degrees, right? Okay, 160 degrees. I want to know what, like, this arc measure is. What? What? What?
360 minus that.
You are just too smart. All the way around. See, and he wasn't even here the other day. All the way around, it should be 360, yeah? So that means these two added together is going to be 200, right? Because 360 minus 160. But I know that those arcs are the same because the chords are the same. So each one of those arcs is going to be 100 degrees. Do you see how that works? They're going to do that stuff to you on your homework assignment. And I don't like that because they didn't give us a practice problem like that. Whatever. Okay, ready? Good? All right, example 3. Here we go. Information that we have. We have the measure of arc EFG. So this distance right here, or that measure, is 120 degrees. Okay. Find the measure of arc FG. FG is this, just this guy. Do you think it's 60 degrees? Is it half? I believe it. I believe it. 60 degrees. And then they want to know what the measure of EG is. So from here to here. What you thinking? Is it 7? 3.5 is referring to just this length right here. Is this also 3.5?
Looks like it.
Because it makes a T. It makes a 90-degree angle T, which means the left and the right side, like a kite, are the same. So the whole thing across is 7. Yeah? You see how that works? Perfect. Okay. Example 4. This one's the this one's the hardest one. Okay, pay close attention to this one. This one's hard. All right, we have to really use some thought when we're doing this, okay? All right, things that are true, just looking at the way that this is set up. Is this the same as this? Yes. There you go. Is this the same as this? No. Not necessarily, right? Okay, so keep that in mind. All right, here we go. The diameter CD from here to here is 12. 12, I don't know, inches? 12 inches. Okay? From one edge to the other is 12 inches. Got it? Diameter. All right. They say FH. So from here to here is 10. I know that means that this is 5 and this is 5. Yeah? And this, how far is it from here to here? This little guy. 6, right? And this is 6. Boop. They want to know, I'm going to get rid of all that stuff. They want to know EG. Is it EG or GD? EG. They want to know EG. So if this is 6, does that mean that's 3 and that's 3? No. Not necessarily. Could be, but not necessarily. So what are we going to do? This is like really hard to come up with. 5 is this length right here. This is 5. Yes, how? Oh my gosh. That was like really hard to come up with. Okay, ready. Here's what Ethan says. F to E. If we connect that and we make a triangle out of this, how far is it from F to E? How long is that?
6.
That's a radius, right? Isn't F to E a radius also?
Yeah.
Right? So that would be 6, right? All of the other radius is 6. So I have 6, and I have 5, and then I have this length right here. Can we do the Pythagorean theorem? Yeah, that was like a really tough, like, grasp thing to concept. Concept to grasp. There you go. Okay? Which side's side C, by the way? 6. X squared plus 5 squared equals 6 squared. X squared plus 25 equals 36. If we subtract 25, x squared is 11. And take the square root. 3 point something. 3 point, I think it's like 3.32 or 3.23. I don't remember. 3.32. So it's a little bit over halfway, 3.32. And then this would be like 2.68 or something like that, right? In order for all of it to add up to be 6, right? Yeah? So 3.32 is that little distance. But the key there was knowing to slap that little third side in there to make it a triangle. Yeah? That's kind of a little tough thing to grasp. Okay? All right, that was example 4. On to example 5. And then we are done. Here we go. Okay, check this out. We have a chord right here that is making a perfect T with like this. And that's not even a radius. That's like a little whatever piece, right? And it's also 8 right here and then this chord right there, right? Are those two chords going to be the same length?
Yes.
You think so?
Yeah.
I believe so. Let's say, just for example, let's say I put a piece here that's 10 inches long or whatever, and I make a chord going off of that. The further out of the circle that you go, like this is 10 inches out, that chord's going to be smaller. True? This one's only 8 inches out. Like let's say I go 4 inches out and I make a chord, right? Okay? So not all chords are going to be the same length. If I'm only going 4 inches out, that chord's going to be different than 8 inches out or 10 inches out, whatever, right? But the fact that both of those are 8 inches out means, or 8 whatever units out, means that that chord will be the same as that one. Got it? Woo! Okay, PQ is 3x minus 4. This length is 3x minus 4. Then I know that RS is 14. And they want us to solve for x. 3x minus 4 equals 14. Add the 4, 3x is 18. Divide by 3, x is 6. Do I plug back in?
Nope.
No, he's done. Pretty easy-ish. Okay, all right, I know you're going to ask on number 2, possibly, because number 2 is weird. Okay, so let's talk about number 2 real quick. Go to number 2. Homework is 2 through 20 evens, but let's talk about number 2 because I have like weird things going on, right? Okay, so let's look at this. This is a chord, right? And this is a chord. And this arc is 116, which means this arc is 116. True? But they want the measure of this central angle right here.
That's going to be the same.
Is it going to be 116?
Yeah.
Yeah, because we've said before, whatever this angle is the measure of that arc, right? So they just gave it to you kind of weird. Okay? All right, there you go. There's number 2, 116. All right, do the rest. Wonderful? Ask questions if you've got them. Good, good, good. All right. Goodbye, whoever's watching. Olivia and Remington.